Welcome pre-cal students to class today on this Monday the 31st, March 31st. Hope you guys are doing well. Hope you're ready to learn some math today. Some quick announcements here. You will have a test on Monday. If you're not going to be able to make it, please let me know no later than Sunday. You will have a review sheet this Friday for your test on Monday. And by the way, welcome to the rare moments in this class. I think your review sheet is about 21 problems. Can you believe that? They're usually at least 40. The last one was 50, so this will be a little smaller review sheet than usual, and that won't happen very often, so don't get used to that, okay? All right, quizzes are due Tuesday. Quizzes are due Tuesday, so make sure you get those turned in, completely done, all questions asked and completely finished. Stay on top of your integrity sheets. Integrity means you're honest. You do the work, and if you don't, you tell me, okay? So all integrity sheets will be due Monday when you come to my house, okay? If you got any questions on these announcements, contact me and I will try to help you. Grab your notebooks, pens, pencils, papers, calculators, and let's roll. We are going to study something today called synthetic division. Understand something. Synthetic division does two things. It can be used in place of some, not all, some long division problems. Isn't that good news? I mean, think about how long it took to do long division of polynomials, okay? Number two, synthetic division can be used to evaluate functions at a given value, okay? Instead of using direct substitution, you can use synthetic division, all right? We will be looking at both of these cases today, okay? Case number one and also case number two. Long division was an extensive process, correct? Sure it was. What if I told you that we could replace long division, in some cases, not all cases, with synthetic division? We can do that, and here's how we do it. It's really a neat process. First, understand, please listen guys, first understand that synthetic division can only replace long division when the divisor looks something like this, x minus 2. And when I say something like this, I mean the following things. Number one, I probably should have typed these out for you. I would take some really good notes on this. Number one, it has to be a binomial. Number two, the coefficient of your x term here has to be a 1, and the power of your x has to be a 1. And then lastly, this has to be a constant term. It has to be a real number, a number without a variable. Okay, let's go over that again. First of all, you can only use synthetic division in place of long division when the divisor looks like this right here. And what I mean by that is this. Now my pen is really freezing up, so be patient with me if it does some weird things like that, okay? Number one, it has to be a binomial, your divisor does. Number two, the coefficient of your x has to be a 1, and the power of your x has to be a 1. And then number two, this has to be a constant term, okay? So having said that, don't forget to always check and make sure your divisor fits into those stipulations before you try to use synthetic division, okay? All right, moving on. Steps for using synthetic division in place of long division. Here they are. Please copy these down. You'll probably have to pause the video. Number one, make sure the divisor and the dividend are both written in standard form. That's very, very important. Number two, set the problem up in synthetic division form. I will teach you how to do that. Be sure to put in zeros and change the sign of the constant term of the divisor. I will teach you all of this later, what that means, okay? Number three, bring down the first number. Next, you would multiply and combine over and over until you have reached the end of the problem. I will teach you how to do that. Step 4, write your final answer in polynomial form. I will teach you how to do that, okay? All right, moving on. Let's try 3 of these problems, okay? So take some really good notes, follow along, and let me teach you how to use synthetic division in place of long division. And I think you're really going to like it, okay? I really do. Okay, here's the first problem right here. Go ahead and copy this in your notes. And this is a division bar right here, okay? So we have x cubed plus 2x squared minus 5x minus 6 divided by x plus 1. Now, first of all, I didn't put this in your steps over here, but make sure you can use synthetic division. Remember, I taught you back here how your binomial, how your divisor has to look like this right here. It has to be a binomial, lead coefficient of 1, a power of 1, and this has to be a constant term. Now we have that over here. Your coefficient here is a 1, your exponent is a 1, we have a binomial, and you have a constant term right here. So we're good, but always learn to check and make sure, okay? All right, here we go. So we can definitely use synthetic division. Now what you did in the past was this. Remember, what I taught you last week was this. Do you remember this? This was called long division, right? Minus 5x minus 6. And we had to do that real long process. Hopefully you guys remember that. Well, instead of that, we're going to use synthetic division. Step 1, make sure the divisor and dividend are both written in standard form. Well, this is written in standard form, x cubed, x squared, x, so we're fine. And this is written in standard form also. Cross off step 1. Step 2, set the problem up in synthetic division form. Be sure to put in zeros and change the sign of the constant term of the divisor. Please take some good notes. Here we go. Here's how you do synthetic division. All right, please watch carefully. You put a little half a box like that, put a line down here. Now, you're going to take the coefficients of your dividend right here, and you're going to put them right here. So the coefficient of your x cubed is 1, the coefficient of your x squared is 2, the coefficient of your x is negative 5, and your constant term is negative 6. Okay? That's easy, isn't it? You take the coefficients of your dividend and you put them right here. That's so easy. So I'm setting the problem up, step 2, I'm setting the problem up in synthetic division form. By the way, notice this, change the sign of the constant term of the divisor. Okay, fine. Here's my divisor right here. What's your constant term? Positive 1, so I'm going to change the sign and put a negative 1 right here. I could explain why I'm not going to do that now due to the length of the time, but trust me, there is a reason for that, and I might hopefully be able to explain that to you one day, or maybe when you all come over Monday, I can quickly explain why we do that, okay? Now, there's one other thing step 2 says. Set the problem up in synthetic division form. We did that. This is how you do that. We also changed the sign of the constant term of the divisor. We did that. But look, be sure to put in zeros. Now here's what that means. Would you please watch carefully? See this dividend right here? If you would have been missing a term, let's say the dividend would have been x cubed minus 5x minus 6 in place of this, okay? Well, do you notice how you're missing an x squared term? You went from x cubed down to x to the 1. Do you see that? Then you would have wanted to put a 0 right here. In other words, the coefficient of the x cubed is 1. The coefficient of the x is negative 5. But notice how there was no x squared term. Well, if you're missing a term like that, then you have to put a 0 in place of that missing term. Okay, now let's go back and look at the original problem very quickly here. Do you notice in the original problem we're not missing any terms? Our highest exponent was a 3, then we went down to a 2, then even though you can't see it, we went down to a 1, and then we went down to a CT, a constant term. You weren't missing any terms, so there was no need to put a 0 in, but sometimes you will have to put zeros in. In fact, one of the 3 problems we're going to do, you're going to have to do that, okay? So now remember, this is brand new, so it's going to be a little confusing at first, but we're going to do 3 of these, okay? So step 2 is totally done. I set the problem up in synthetic division form. I put in any zeros that I needed to, which I didn't, and I changed the sign of the constant term. So we're totally good. All right, we're totally good. Moving on now to step number 3. Step 3 says bring down the first number. Well, here's your first number, and I'm going to bring that number down and put it here. Isn't that easy? So step 3 says bring down the first number, and I've done that. Now, if we continue to reach step number 3, it says next you would multiply and combine over and over until you have reached the end of the problem. All right? So, here we go. And by the way, students, I apologize. I keep pausing the video. My children keep asking me questions, so I'm going to pause the video here. I'll be right back. Okay, I'm back again, guys. So step 3 says bring down the first number. I've done that. And then step 3 says multiply and combine over and over. So watch what I mean by that. See this number here? You multiply it by this number here. And -1 times 1 is -1. Put it here. And then combine these two numbers. So -2 and a +2 and a -1 is 1. Now we multiply and combine again. So now we take this number times this number. -1 times 1 would be -1. And then we combine these two numbers. If you combine -5 and -1, you get a -6. Now we do it again. We multiply and combine. So we take this times this. -1 times -6 would give you a +6. Combine those and you get a 0. Now you won't always get a 0. Sometimes you do and sometimes you don't. Okay? Now let's talk about this. Whenever you get a 0 here, do you know what that means? Take some really good notes on this, okay? Whenever you get a 0 here, do you know what that means? That means there is no remainder to the problem, okay? And if there would have been a number here like 8, then 8 would have been your what? 8 would have been your remainder, okay? But since we got a 0 there, that means there's no remainder, all right? Now, what do we do with these here? Well, I'm glad you asked. Step 4 says, write your final answer in the form of a polynomial. Okay, no problem. Remember how all of these numbers up here were coefficients? Remember 1, 2, -5s, 1, 2, -5, -6, remember that? Well, that's what these numbers are down here. These numbers are coefficients. So here's what we do. In your original problem, what was your degree of your dividend? 3. Let me ask that again. In your original problem right here, what was the degree of the dividend? 3. Well, you always subtract 1 from this number here in your head. Always go 1 less than that. So 3 minus 1 is 2. So this number here would be your coefficient for x squared. This number here, +1, would be your coefficient for your x. And this number here would be your constant term. And there's your answer. In other words, let me show you what you did. Please look at this, man. Don't get frustrated. Don't be confused. I'm going to explain this. Watch. If you would have done long division the way I taught you last week, x goes into x cubed, x squared time, do your multiplication, you would get this right here. Go ahead and subtract. You would get 1x squared, bring down your -5x. X goes into x squared, x times x is x squared. X times 1 is +1x. We're going to subtract. You would get -6x, bring down your -6. Multiply, you get a -6. Multiply and subtract, and these cancel out and your remainder is 0. So if I would have done long division, look what I would have got. And look what I got right over here. The exact same answer. And believe me, I did synthetic division very quickly. Trust me. I did long division very quickly over here. Trust me, long division is not as fast as synthetic division. So I'm getting the exact same answer out right here that I would have got if I would have done long division, only I'm not going to do long division. Today I'm going to learn a new way, which is called synthetic division, okay? So let's go over this again. What you do, once you're done with doing step 3, then you take these numbers here and you write them like they're a polynomial, just like that. Okay, so I have a question for you. Please watch this carefully. Did x plus 1 go into this evenly? Yes, it did. There was no remainder. Remember, remainder of 0. So you could say that x plus 1 is a what? Do you remember? X plus 1 is a factor of this polynomial right here. x plus 1 is a factor of this polynomial right here. Pretty cool. Okay, and we know that because we got out a remainder of 0. And by the way, on a test or a quiz, if I asked you to divide these using synthetic division, here's your answer right here. You did it. Let me get a drink here. You successfully and completely divided this polynomial by this polynomial here, only you didn't use long division, you used synthetic division. Let's try another one and see how you do, okay? Because practice is really, really helpful for you guys, okay? So here we go. Let's try another problem. Okay, let's go ahead and slide this problem out of the way. Let's pull up the next problem here, and let's see how we do on this. Okay, now here you're going to have to put some zeros in, I believe. So, okay, step number 1, make sure the divisor and dividend are both written in standard form. Well, this is written in standard form. This is written in standard form, so we're good. Let's move on to step 2. Step 2, set the problem up in synthetic division. However, be sure to put in zeros and be sure to change the sign of the constant term. So let's go ahead and set this up in synthetic division. First of all, I'm dividing by x minus 3. So my constant term is a negative 3. So what I'm going to put right here in the box would be a positive 3. Please don't forget to always change the sign of your constant term. Next, we're going to put some zeros in going across here, okay? So the coefficient for my x cubed is 2. Notice there's no x squared. It should go from x cubed to x squared. There is no x squared, so I'm going to put a 0. The next should be an x term, and I have that, so I'm going to put a positive 5. Next should be a constant term. If there is no constant term there, you would have to put a 0 over here, okay? There has to be a constant term, all right? So let's go ahead and put a 7 here for my constant term, and now we're good. We completely did step 2. We set the problem up in synthetic division form. We changed the sign of the constant term and put it right here, and we put zeros in where necessary. So now let's go ahead and move on to step number 3. Bring down the first number and then multiply and combine over and over until you reach the end. So bring down your first number, and here we go. Multiply 3 times 2 and you'll get a 6, and then combine these two numbers here and you'll get a 6. And then multiply 3 times 6 and you'll get 18, and then combine these two numbers here, 5 and 18, and you'll get 23, and then multiply 3 times 23, multiply 3 times 23, and you will get, let's see, 69, and then combine these two numbers here and you will get 62, positive 62. And so this number right here is your remainder, okay? So here's how you would write your answer, okay? Remember, you look at the degree of your dividend. Your degree is 3. Go 1 less than that, that would be a 2. So your first term is going to be x squared, and this is the coefficient right here, so 2x squared. Next is a 6, so plus 6x. Next is your 23, that's your constant term, 23, and then your remainder is 62, so plus 62 over, now what was your divisor? Your divisor was x minus 3. Now to me that's a million times faster than doing the long division. So you just divided this polynomial here by this polynomial here, and there's your answer, just like that. Now, was there a remainder? Yes. So did x minus 3 go into 2x cubed plus 5x minus 7 evenly? No. So is x minus 3 a factor of this polynomial? No, it is not. No, not a bit. Okay, so there, you did it. Okay, let's take a look at one more problem, and then we'll go on to the rest of your notes, and they're actually a little easier, so a little quicker than this. And plus, we're getting faster and faster at synthetic division, so this should become a little easier for you guys, okay? All right, let's try this problem here. Okay guys, I'm going to go a little faster on this problem here. So here we go. Make sure the divisor and dividend are in standard form. They are both in standard form, so we're good there. And let's go ahead and set this up in synthetic division. And this is kind of a trick problem, okay? Right away you should notice something. You cannot use synthetic division on this problem because if you'll look at your divisor, it's x squared plus 5. And remember, to use synthetic division, there has to be a 1 here, and there is. It has to be a binomial, and it is. There has to be a constant term here, and there is. But this exponent right here has to be a 1, and it's not. So first of all, the reason I gave you this problem is I wanted to remind you to always check and make sure that you can use synthetic division before you try to use synthetic division. Now we're going to go ahead and change the problem, and we're going to get rid of this 2 right here, and we're just going to pretend it's x plus 5, okay? But make sure you do that. Always check, okay? All right, number 1, make sure the divisor and the dividend are both in standard form. They are. Number 2, set the problem up in synthetic division form. Don't forget we changed the sign of the 5, so we're going to put a -5 right here. And then we're going to add some zeros. The coefficient for your x to the 4th is 3. Notice there is no x to the 3rd power like there should be, so we're going to put a 0. Next is x squared, and your coefficient is a -5. Next is an x term, and the coefficient is a 1, so we're going to put a 1. And there is no constant term, and there should be a constant term, so we're going to have to put a 0 right there. Okay, and now we have it all set up in synthetic division, so we're going to go very quickly now and work on step 3. Now, step 3 says to bring down the first number and then multiply and combine over and over. So we'll go really fast. Bring down your 3. Multiply -5 times 3, -15. Combine, you get a -15. Multiply -5 and -15, that's a positive 75. If you'll combine these two, you'll get a positive 70. And sometimes the numbers will get really large. That's not that unusual. Now, -5 times 70 would be negative 350, I believe. And then combine these two and you will get a negative 349. Let me grab my calculator real quick. Negative 349 times 5 would be negative, no, it'd be a positive, positive 1,745. And then combine those two numbers and you will get 1,700 and, let me fix that real quick guys, 1,475. Okay, so step 3 is done, guys, and now we realize we do have a remainder right here. So let's write our answer very quickly. The highest power over here was a 4. Go 1 less than 4, we're going to start with a 3. So our first term is x cubed. Okay, bring down your first coefficient, 3. Then bring down your -15, -15x squared. Bring down your 70, that would be 70x. And then bring down your negative 349, and then your remainder would be 1,745 all over x plus 5, which was your divisor. And that's a lot faster than long division, okay? All right, moving on. Here we go. Now, remember, synthetic division can also be used to evaluate a function at a given value. This method can be very helpful. Here are the steps. Copy these down. Set the problem up in synthetic division form. Be sure to put in zeros where needed. Bring down the first number. You know this step already. Bring down the first number. Multiply and combine over and over and over. Look at step 3. The last number at the bottom right is the answer. The last number at the bottom right is the answer. So, I will show you what that step 3 means in just a second. Okay? So with these 3 steps right here, let's go ahead and take a look at 3 problems. Okay? Here we go. This is really neat stuff. Let's practice the problems. Here we go. All right, here's problem number 1. And hold on 1 second. This is not how I remember it. There we go. All right, there we go. Okay, guys, so here's the problem that we're going to evaluate. Now, usually, if I told you to evaluate this function at f of -4, you know what you would do. You would put a -4 in for x to the 3rd power plus 8, and then put a -4 in here, squared, and then you would put a positive 8, and then a negative 4, and then a negative 32. Okay, and then we have to do all the math on this and take negative 4 to the third power and negative 4 to the second power and negative 4, then do your multiplication, do your adding and subtracting and all that kind of stuff. Okay, synthetic division is a lot faster. Now, you can do it this way, and I'm not sure what number you would get out. In fact, real quick, I'm going to take my calculator and type this in and see what I would get out, because I want to show you that it does work. So I'm going to take a parentheses, negative 4, raise it to the third power, plus 8 parentheses negative 4, raise it to the second power, and then plus 8 parentheses times negative 4, and then minus 32. Now if I typed everything in correctly, I'm actually getting out 0. So when you do all the math on this right here, you get 0. Now I want to show you how to do this with a synthetic division, okay? So step number 1 says set up the problem in synthetic division form. Be sure to put in zeros where needed. So here we go. Here's how you set it up in synthetic division form. You're evaluating this function at negative 4. So I'm going to put a negative 4 right here in my little box, okay? Notice I do not change the sign like long division. I just simply put a negative 4 here. And now you put all your coefficients. So I have a 1 for x cubed, an 8 for x squared, an 8 for my x term, and a negative 32 for my constant term. Now, there were no zeros that I needed to put in, so that's fine. Now, step 2, bring down your first number, and then do your usual steps. So bring down your 1, negative 4 times 1 is negative 4, combine you get 4, multiply you get a negative 16, combine you get a negative 8, negative 4 times negative 8, positive 32, and you get out a 0. See how fast that was? That is so much faster than direct substitution up here. It's really, really fast. Now notice step 3 says the last number at the bottom right is the answer. Well, what did I have here in the bottom right? 0. What did I get out up here? 0. It works. So when you put negative 4 in for x and you do all the simplifying, you get out 0. So f of negative 4 equals what? F of negative 4 equals 0. Or in other words, negative 4 comma 0 would be an ordered pair if you were graphing this. Or in other words, you could also say negative 4 is one of your what? Are you getting this, guys? Listen, negative 4 is also a what? And my pen is really messing up, guys. I apologize. I'm not sure what's wrong with it. Negative 4 is one of your zeros. Or in other words, negative 4 is one of your x-intercepts. How do I know that? Because you put in what number? Negative 4, and you got out what? A 0. So this is really, there's a lot of things to think about here, okay? But what we're trying to focus on right now is evaluating a given number for a function, okay? So let's try another problem now and see if this will become hopefully a little easier to do. All right, let's try this problem here. Okay, let's evaluate 2x to the 5th minus 3x cubed plus x at f of negative 1, okay, using synthetic division. So very quickly, I'm going to put a negative 1 in my box, and then I'm going to list out my coefficients. I have a 2 for my x to the 5th. Notice there's no x to the 4th, so I put a 0. For my x cubed, I put a negative 3. Notice there's no x squared, so I'm going to put a 0. For my x term, I have a coefficient of 1, so I put a 1. And then notice there's no constant term, so I put a 0 for my constant term, okay? And now let's go ahead and get started. So we totally set the problem up in synthetic division, and now I'm going to go really fast. Bring down your 2 and put a 2 here. Multiply, you get a negative 2. Combine, you get a negative 2. Multiply, you get a positive 2. Combine these two numbers, you get a negative 1. Multiply, you get a positive 1. Combine, you get a 1. Multiply negative 1 times 1, that's a negative 1. Combine, you get a 0. Negative 1 times 0 is 0. Combine, and you get a 0. Now that's a coincidence that we got a 0 again. But there you go, there's the answer. The answer is 0. So in other words, if you substituted negative 1 in to this equation, you would get out a 0. Now let's just check and make sure if that's right. Put a negative 1 in here. Negative 1 to the 5th power is negative 1 times 2 is a negative 2. Now put a negative 1 in here. Negative 1 to the 3rd power is negative 1 times 3 is a positive 3. And then we're going to put a negative 1 in for x. Positive 1 times negative 1 is negative 1. If you combine those numbers, you would get out a 0. Now you might say, well, Mr. Earhart, it was actually faster here to use direct substitution to get out a 0 than it was to use synthetic division. And you're right, sometimes it would be faster to use direct substitution, but a lot of the times it's a lot faster to use synthetic division. Okay, so now we're using synthetic division to evaluate a function at a given number. Okay, let's try one more problem and then we're finished for the class period, and I'll give your homework to you. Okay, all right, here we go. Let's go ahead and see if we can solve this problem here. All right, here we go. Now this will be a little more difficult because notice we're going to use I, so it is going to be a little more work involved. Okay, but stay with me and we should be able to do this. By the way, this should be x cubed and this should be 3x squared. There we go. So be sure and fix that. Okay, here we go. Step 1. Let's set the problem up in synthetic division form. We're going to evaluate this function at the letter I. So I'm going to put I inside my box, and now let's list out your coefficients. Your x cubed coefficient is 1. For x squared we have a negative 3. For x I have a positive 1, and for my constant term a negative 3. So there was no need to put any zeros in. Okay, let's go ahead and work out step 2 here. Okay, step 2. We're going to bring down the first number and then multiply and combine over and over. So I times 1 is just I, and when you combine these two you'll get negative 3 plus I. Do you see that okay, students? You can't really combine negative 3 and I, so we put negative 3 plus I. Now we take negative 3 plus I and we multiply it times I. Okay, so we would get this right here. We would get negative 3 plus I squared. Everybody see that okay? Negative 3 plus I squared, because I'm going to multiply I times negative 3, that's negative 3I, and then I'm going to multiply I times I gives me I squared. Now remember, let's use our heads here a little bit. For I squared you can really substitute negative 1. So you really have negative 3 plus a negative 1. Let me say that again. For I squared you can substitute negative 1. So you really have negative 3 plus a negative 1. So really this whole thing becomes negative 4. Now combine these together. Combine your 1 and negative 4 and you'll get a negative 3. And now we're going to multiply again. So I times negative 3 would be negative 3I, okay, and you can't combine those, so well you can, but you write them side by side. So you would write negative 3 minus 3I, okay, and that would be your remainder. That would be your remainder. Okay, so here we go. Let's go ahead and write our final answer. Notice our highest degree was a 3, so we start with an x squared. So my first number here is a 1, so I would have 1x squared, and then I would put parentheses. I would have this right here, plus, and then put parentheses, negative 3 plus I. That whole expression is your x coefficient. Okay, so the 1 was your x squared coefficient. Negative 3 plus I is your x coefficient. Okay, and then the next number is a negative 3. That's your constant term, negative 3. And then for your remainder, you could put plus and then negative 3 minus 3I all over I. Okay, because that's what your remainder would be. Now that's what you're divided. Well, actually I take that back and I apologize, guys. I forgot that we're not doing long division, and that's my fault, and I do apologize. I forgot that we're just doing synthetic division for evaluating. So my fault. Your teacher's getting a little old here, guys. Step number 3 says the last number is the answer. So what we have is this. When you substitute I in to this function right here, you get this out right here. So you could say f of I equals negative 3 minus 3I. There we go. That's how you'd want to write your answer. And again, sorry about the confusion down here. That would have been the answer that I had down here if we were using synthetic division for long division like we did earlier in the class period. But right now we're just evaluating this function right here at I, And so there's your answer. F of I equals -3 minus 3i. Okay, so that's it on synthetic division, using it for long division and also using it for evaluating a number. All right, let me give the homework to you, and then you can start working on that. Here's your homework assignment, page 287, 11 through 21 odd, and then 23, 25, 31, and 33. And Matthew and Caleb, I did cut that back significantly. This video has gone much longer than I thought it would. And so just so you know, I paused the video a second ago and I changed this. It was going to be quite a few problems, 14 or 15. I've cut it down to 6, 7, 8, 9, 10 problems. So that's about 1/3 of the assignment cut down. Okay, so there's the assignment, 287, 11 through 21 odd, and then 23, 25, 31, and 33. Call or email if you have any questions. I hope you guys have a good day today.